So, hi guys, let's start. Well, I think we can begin from just okay. Do you see my screen? Anyone, please?
Yes. Yes.
Yeah, great. So, yeah, you can chat in our meeting chat. But for me, it's preferable to answer questions so just a voice because it's just I can just hear it in time. So, but of course, I will check chats like every 10 minutes. So our first seminar will be about some word embeddings. Do you have some experience or some knowledge in word embeddings in NLP tasks in our previous maybe I don't know projects or something else? Do you hear about this topic? How detailed I have to explain it? So it's essential for our seminar. It were questions, guys. Some, please, anyone, anybody?
I don't think so. We had it.
Okay, okay. So let's
I
move.
think we know that embeddings is some kind of vector representation.
Yeah, you're quite right. So embeddings is a vector representation of the word of the some tokens. Yes, tokens can be whatever we want. For example, just in a simple case, it can be like a char. Yes, like one letter, like A, B, C, and we can just enumerate our alphabet. Yes, for example, A is 0, B is first, etc. Yes, and we can create our words like represent in these code, for example. Yes, like cat, it's like C-A-T, and we can change the letters to numbers. So it's the basic idea. It sometimes we can do in a such style, but of course it's wrong. It's not modern experience to do so because we have great libraries and frameworks to create great embeddings. For example, BGE, BGE embedding M3. So it's I think the most great model for embeddings. I just show it in a Hugging Face. Hugging Face platform. It's like yes, this one. So yes, it's just for your knowledges. Yes, for something additional knowledge. Yes, you can. It's here. We can find a paper. Yes, of course, it's like generally it's arXiv paper, so we can find it some theoretical information about how these PG embeddings work, how they create. Yes, and it's really interesting paper. I would advise you to read it. Yes, in the future, or you can use this model from Hugging Face platform just in your like solutions, your projects, etc. So yes, but of course we we couldn't start with big embeddings right now because it's really sometimes complex topics, and we have to start with something more simple that it. So, and I really advise you this short article, like on Medium. It's about guide to word2vec. It's one of the first library for embeddings, like vectorizing words. Yes, and here we can find the simple idea of how it works. For example, like a bag of words, all these terms, terms, yes, and all these like knowledges, all these ideas was at the lecture. So, but here we are on seminar, so I couldn't explain everything in like in theory. Yes, what was in lecture. So you can just see some recordings or to I don't know, to read some additional sources. Yes, I provided. So yes, and here we can see like I think the basic idea that we have some words, yes, and we can create like words with some tokens. Yes, it's like can be like part of words or can be like chars, yes, letters, for example. Yes, and then we just want to create something that really similarly for another. For example, want to make it vectors. Yes, the main famous I think picture with what to vec, it's this one. So yes, mathematical. Okay, I need this. So yes, for example, all it's like the traditional to start with such a picture or about the word embeddings, like how it works and for what purpose we create this. Yes, for example, we have some vectors. Yes, of our both our words, about our bag of words. For example, it can be a vocabulary or something. Yes, and for example, like 10,000 words. Just for example, yes, and in this vocabulary we have just men and women. Yes, it's like two words, and we have also king and queen. So, and what we want of our system, our library, yes, we want to create such vectors of, above our words that in the vector space we can we can represent these vectors like a point, yes, for example, like a man here and a woman. And the distance between men and women can be similarly, yes, like equal from queen, between queen and queen. Why? Because king is a man and queen is a woman. They're not on the same dots like a man and woman was, but the distance, yes, and semantically reason between these two words like king and queen is the similar, like the same, just between men and women. And that is was what we want. Yes, because if we have, for example, if we have vectors man, women, and kin, so it's pretty simple to find the like the point, yes, in a space, in a vector space of queen vector. Yes, and so we can we can leverage, yes, these vectors in our solutions, like really vectors, and we can create like our line algebra, for example, yes, for it, and we can work with words. We can work with text, semantic sentences, paragraphs, books, and etc. So that is why we need it, because we couldn't put in the model just our word man, yes, and then put a women, and so model doesn't understand char format or string format. Yes, we have to represent it in some float, in the float or vectors. So yes, just out of curiosity, so this many people like enthusiasts of ML engineer, so they create a vector space just from a word to vec, and this plot does is wrong, so it doesn't work such like in this image, but the sense, it makes sense, yes, of course, and the main idea is correct, is absolutely correct. So let's continue. So if we create some such vectors, yes, for example, we can do it, yes, it's pretty, no, not how we can create it. Yes, for example, we have our input vector of 10,000 words. We have 10,000 positions. Here we have something like some position in the cursor, like ants, etc. Yes, you can read the article more like carefully. Yes, I want to explain it really fast. Yes, and we have like a softmax classifier output layer. Yes, for a like represent the probability that the word, if we some choose, yes, and it's near the like embedder, for example. Yes, so and here we learn these network and create like hidden layer linear neurons. Here we have 300 neurons, but we can vary this number, and this number exactly is the um, shape of embeddings. Yes, and just that's right. So that's all. We just train this network. We have too many data sets of the words, of the text. Yes, and here we can train a lot like words. Yes, we have now data. So and then what we can we just take we just on the inference we can just put through our network or pre-trained network all our words or data sets, for example, yes, and take this representation hidden layer, yes, and it will be like 30 neurons, yes, and we have 10,000 words, 30 neurons, okay, and we have for each word of each word we have 300 features, yes, Unicode features, and that's all. That's all. We have our embeddings, yes, our words that it's so final what we want. So it's really fast description about what to back. I really advise you to read an article. Maybe I can provide you some more sources. I just remember one of them. Yes, I remember Seminarist course. Yes, oh, here it is. Yes, this is really useful and I think one of the most understandable source. Maybe you know about it. Yes. Yeah, of course. I just so and here we have some GIFs with understandable images, how it works, how exactly we take our vocabulary, our some tokens, symbols, yes, some semantic distribution, yes, for example, here we find the word which we don't know, for example, yes, like here it is the pretty example for you, yes, you don't know that that's green, what it is, the word, I think probably no one of you know, I don't know. So, but in the from the context of this word, yeah, yes, the bottle of the green is on the table. Everyone likes this green, makes you drunk. We make this green out of corn. Of course, we can understand about what we talk, what text green is. So, do you have some thoughts, some opinion about it? Let's check
Alcohol.
it. Yes. So, what it is? What it is?
This green is alcohol, right?
Yes. So it's a kind of alcoholic, of course, but of course we're talking about not about alcohol. We talk about machine learning, and it's pretty example that you understand from the context the word meaning which you don't see before, you don't know before. So and that's why we want to create our embeddings too. So, yes, because you want to understand this context. Yes. So and here our yes example. I just so say about it. Yes. So and what to back here it is. Yes, and we have some. So we have the word, and we can just compare our word. Yes, our central word with context of the words like right and the left, like the probability. So and we just iterate from our sentences, text, books, etc. Yes. Here's some maths. It can be looks like a whoa. So it's like complex, but it's not really. It is. So it's not really complex math. So just here we have so create understandable meanings of each part of formulas. Yes, and here it is this our embedding dimension. So what I've told you just a couple of minutes ago. Yes, and here that's all. That's all. Yes, and how to train this one at a time. So this is a really useful source, and I just share you this link. So it's kind of it. So I just sorry. So where's you? Ah, here it is. So then avoid not course, but I really recommend you to see this course about here, if you just notice, so it's a really complex NLP course, which started with from body embeddings, then one-hot vectors, distributional. I'm sorry, not this. NLP course started with word embedding, but then we moved to the text classification, language modeling, sec-to-sec, attention, transfer learning, etc. So, but this will be continued. I think some self-attention, transformer architecture, but I think NLP works a lot. So that's why maybe this continued information will be not so soon. Yes. So text classification, yes. So here, so I really recommend this course, yes. And about this article, yes, word to vec. I think it's not something like guide, but I really recommend you Lenovo. It's more preferable because it's more like math understandable, and I think with some GIFs and some really detailed information. So yes, for future our conversations, I will share you with some links about the PCA, like principal component analysis, like is so PCA you can find here, but don't hesitate to find some your resources, yes, and find some in the search internet yourself, because of course I provide you some preferable just for me resources, yes, what I really think. I think that it's can explain something fast and understandable. But if you want to see like YouTube channel about like principal component analysis, it really I think will be really useful for you, yes, to understand like in the picture, in the video, with some like, of course, like some pipeline how to create. So, and you just two resources, UMap and TSNE. So I couldn't explain you these techniques. Just, oh, right. So great. I don't forget this one. Spelling. Okay. I don't like so. Please. Okay. Great. So I just told you now about some PCA. Oh, I just I closed that. Okay, no matter. Like PCA, UMAP, and TSNE, so which are closed. It's the simplest things for a cluster relation information and for make it low dimension. For example, if you have some 3D, three-dimensional space of the vectors, you can use like PCA or UMAP or TSNE, yes, to represent this three-dimensional space to a two-dimensional space, like on a plate, yes, and then to plot it in your computer and understand where the vectors are exactly. Of course, it has a not really accuracy, as accurate, like yes, but it's safe. I think relations between vectors. So each of them, yes, the principal component analysis. So he create the main component of the data, and he So it so this method like just project on this main component our data. So and then draw it. So you can find. I really recommend you and advise to find some videos about PCA on YouTube and to understand how it works. So UMAP makes something like this. Yes, something similar. Yes, it creates from the high dimensional to the two-dimensional, well, from low dimensional space, but make it with some complex things with like some graph, yes, with age and with like constant on these ages. So it's really complex to understand like in the first time, and of course to explain it like in a seminar with like in a fast way. So, but you can, for example, move these extent. Yes, it's like the space around your dots, your point vector point. Yes, and then you can find some nearest. Yes. Oh, and we create some graphs. Yes. So graph, and we just like connect with some similars. So, and T and E make something else, something dissimilar, like PCA and UMAP, but it save the relations between vectors. So I mean, if the distance was between your two vectors in your vector space was 100, I don't know, items, something else, yes, 100. So if present through TSNE method this vector space to another space, to like low dimensional, yes, it like save the relations, not 100, but it decrease all these relations, yes, all these distances between the vectors, like in the equal shape, I think so. If you have like 50 and 80, you just, for example, yes, your return or your result will be like 6 and 8, yes, where low dimension like in 10 times, yes, and it will like we have the same relations, yes, like 6, 8 on 60 and 80. Yes. Oh, I forgot to turn my camera on. Okay, so I'm sorry. I think blur in background. Okay, I think it's okay. Well, let's start. So this 30 minutes will be some about some talks, yes, about our first seminar and about some, I think, essential knowledges about what we want to explain here, what we want to work with it, yes, and of course it's like prerequisite knowledges for understanding our seminar, yes, and I advise you to find more profitable sources for you, exactly for you, and to find some information. So let's start. I just create my seminar like this notebook where we're able to see like the work of port embeddings, yes, and I just solved it. So without extra part is extra, and it's for you if you want to create your knowledge better, yes, and practice it. But of course, some really needs information, so really essential information. So we have some libraries, for example, LTK. I think you don't know this library. If you know, okay, congratulate. So Natural Language Toolkit was one of the first library which can provide some tools for working with text, like semantic, like embeddings, like to do something with text in a like probabilistic or like in a computational sense. So yes, and it's about like this library. That's all. And here we have like impact tokenizer. So about other, I think it's UMap, so NumPy, I think it's okay. String inter tools, I think it's simple. So let's go on. So we have some that's it. Quorum. We have some questions. Yes, questions. Is I don't know how exactly it is. So let's see data. Do you have some questions? Oh, okay. So we have like, okay, about more than half a million. Okay, data. So, and how it looks like, you can see it's like the question. Yes. Now, what is the chemical formula of hydrochloric acid? I'm not a chemist, so I don't know what it is. So, but it looks like this. Yes, like 45. Yes, it's okay. How can I learn to speak English well in non-English environment? It's about me. Okay. Tokenization. Yes, tokenization. It's really vital part of our data preparation. Yes. Oh, turn off your micro, please, if you don't want to say question, to answer a question. Yes, thank you very much. So, so we can here you see. So we tokenize our data, for example, like 50, yes, a 50 item, and it tokenize with a word punct tokenizer. So word punct tokenizer, it like separate our words and tokenize. Why we have to separate our punctuation? It's a question, so maybe some thoughts, some opinions for you. Yes, why we need to tokenize like separately this punctuation in our sentence, for example, like this, yes, and especially this. You can chat it in your meeting chat, or you can say what's your thoughts. Okay, guys. So, for example, Galmarat Europe, yes. Are you here with us?
Could you repeat the question? Sorry.
Yes. So the question is, we just talk about tokenizing. We just see the example with word punct tokenizer. Yes. Why this word punct tokenizer, which separate word, yes, it tokenize like and make this separately, some punctuation. This and this, especially this. Why we need it? Do some opinion? I don't know.
I mean,
thought.
punctuation sometimes changes the meaning of the sentence, so maybe
Yeah.
that's why we need.
You're absolutely right. You're absolutely right. So punctuation is really essential for us. So the meaning of a sentence is yes. So and okay, let's tokenize it. Yes. So we have it. Sorry, I think yes. We can it lower. Yes. So all our words to create like equal format and tokenize all our data. So and we can just put it so you can see something like this. Yes, from the zero hour question. So some asserts, I think everything is okay. So yes, and then we have to use our word to vec. If I don't miss information, so there is the glove from the Stanford. So Stanford make the glove. It like the similar. Oh no, I want to from Stanford. I think it's Stanford. Yes, it's Stanford Natural Language Processing Group. So glove is some similar for the word to vec tool, but if word to vec is understandable, we just train our network, yes, and make it like we took a hidden state. Glove is something with some semantic relations between words, but it's great word embedding creation too. So let's try word to vec. So and we can see here we have data. We can move our size and like send some these 5 times, yes, to proceed. Yes, and finally, like a 5-word window. Window is it's if you remember, so window, and we measure the context. We have the central word, yes, and we can measure the context from the left side to the right side, yes, to understand how our central word relate with the left side, which are the each word, yes, and the right side. So we have this 5-word window. So this model is trained a bit, so because it's not neural network. So yes, and we will see the vectors of our words, all our words in the data tokenizer, because the tokenizer is like the words in all our vocabulary, in all our data. This is our data set quora. So let's see the word anything. So, and here we have some array. Yes, if you want to, we can just see this shape. I think it's 100. Okay, so so that means that each word in our vocabulary in our data set represent each one have like a 100-dimensional vector. So yes, let's see once more. Okay, and model, we can just took the most similar from the bread, for example, yes, and that's it. So rice, our semantic precision, yes, semantic precision, how the the nearest word is, yes, it's a rice, cheese, butter. So we have these products, yes. For example, let's move to the date. Date, what do you want? Yes, date, if I mean date like 18th February, yes, but not date. It's of course it's depends on the context and the context of our data set. So, and we see the date in the meaning of the date, like 18th February, yes, the not really high, not really a lot of words were. So here we see that in that our data set was more like a dating like marry, kiss, marriage, crush, boy, call, etc. So yes, but if we type time, night, day, so yes, we can do. So yes, and here we can use our pretend model from the Clover. Yes, we move to the Clover, and for example, just use this pre-train model. So it's like pre-train on the hard hardboard with the large vocabulary. Yes, we just load this pre-trained model, yes, through API. So, and then we just want to see some positive relations and negative relations with all words. Yes, great. And now, yes, want to create like bread from our previous example. And let's take the time and see. And this will just cut off. Yes, time. So you see that the break way next take a time. So we have some relations with this word. Yes, if we here have some relations like really time, yes, night, day, or lunch. So here we can semantic collocations. I think it's time, break time, way, like next time, etc. So, but let's move to the something negative. Yes, if we want to the time, but not I don't know how to formulate. Yes, like let's move to the time and maybe day. That's a negative. Just so here we have night, something similar. Yes, night, days, break. Yes, some think. Yes, that's all. That's all. Yes, but and here we can just another Yes, the date surprise, date like place, course, fun, see, party, yes, date. And but if we add negative, for example, like I don't know, like let's see here. I forgot. Okay, we have the element. Well. Okay. Crush. So we put the negative weight on crush, and here we have some date with especially like dates like 18 February, for example, rendezvous, specials, weekend, yes, and some another word like from the Hispanic, I don't know, yes, voyage. So I just provide you some examples. So let's visualize our vectors. So we see that it works, okay, it's like sensible. So let's visualize. So we create like the most frequent, 1,000 most frequent words, yes, and for each word we compute our vector with this model, for example, GLOF, yes, and here we want to represent like PCA, principal component analysis. We just talked about it, yes, and here we can like standard scale and that standard standardization of our metrics like normalization, yes, it's like took like a mean and variance. So from each point we just we can just take like a minus mean, and then we derive to our variance. So if you don't know, okay, let's make a like PCA, and it's essential make standard scalar before PCA. It's very vital, and we don't have to make PCA without standard normalization. And maybe you have some ideas why. Maybe some thoughts about why we don't we can't make PCA really great PCA without standard normalization before it. Any ideas, guys? Okay, let's move to the
PCA. So if it's not standardized, then I think it would be like this. Say something is in meters and then something is in kilograms. PCA wouldn't be able to tell like which is less important, because the variance when you calculate it, what actually changes, it would just be all over the place if they're not standardized.
Yeah, absolutely right. Yes. So, but one more reason. So, like the similar of it. Yes, like I think. So, if you have some really high variance of your data, for example, from the 0 to like 1,000, yes, the more feature the more feature is, yes, from 1,000, the more preferable for like the more like preferable component of this feature is, yes, and that's a bias. It's a bias in working with these PCAs that we have to make standard normalization before, yes, and to make our all features like in one dimension, like normalizing. Yes, that's why. And that's why. So see some videos like how PCA works. So let's move to it. Yes, and then let's draw it. We draw like I don't want to explain like draw vectors. It's like the simple function. Yes, based on some mathematical leaf, etc. Yes, and here we can see see exactly like 4 clusters of our PCA, and let's see what it is. So here we can see some. I think here is more nouns. I think yes, but sometimes I think it's the more preferable some pause. Yes, here we can see. Here we can see another language. I think it's the Russian language. Don't ask why, I understand it. So and here we have another language. Okay, I think Espanol. And here some special tokens. Okay, so yes, I think it's a sensible clusterization. You can see it. Yes, so here we have some normal words. Yes, with some relations with it. Yes, for example, just don't find. Okay, it's like normal words. Here we have Russians. Here there's special symbols. Here we have like Espanol. I don't know why. And here some Arabic. Oh, great. So, and here some like a me, no. Okay, so let's move to the UMap, yes, and visualize it with UMap. So, and see some difference, yes. And what we see? We see that the clusters is really separately, right? More separately than PCA. And what cluster is? So here the same cluster of Arabic tokens, yes. We have some clusters of the Russian language, yes, the Russian tokens. Here some special tokens, yes, some emoji, I think some from the Chinese, from the etc. Yes, punctuation. Here too some special tokens. Here the normal English words. Here the large tokens, and one of the largest. Here's some, I don't understand these tokens, maybe some I don't know, bronze. Yes. Here okay, I think it's like the slang words. Yes. Yes, this is in the two special tokens, and here we have like Espanol. Okay, and so on. We have, oh, here is French. Okay, so we see, so you make clusters more separately and more, I think, accurate. Yes, because in like PCA, like we don't understand. We just know that here is like French. Yes, but it is there. So, and now we have some function for get embedding. Yes, it's like a function like represent, yes, our word, like low case or phrase, tokenize, yeah, and then take the average of words. Yes, it's like get embedding from our phrase. Yes, so and understand what it look like. Yes, for example, we have some phrase. Yes, it's like phrase, some data, some question. Why is it so? Okay, what gift should I give to my girlfriend? For example, yes. And what we want? We have some. We just create these tokens, tokenize our each word, yes, and separately, this sentence, yes, and compare each tokens from another, and just retrieve, yes, the most similar embedding, yes, similar vector from our vectorized space, yes, and so it is, yes, this is our embedding from this our vector space, yes, and for example here, and we can just make only 5,000, yes, and then we move to the from UMap, yes, to the 2D dimension, two-dimensional vectors, and we draw it. And here, what we have some one cluster, yes, from these. I'm very sure this never happened to me before, blah, blah, blah. Yes, and what it is, what the similars in our vector, yes, in our vectorized database, what the similars embedding are for such phrase, yes. So in one sector, what is Panera Bread, how much is some mass, uniques, okay, I don't know why. Some camera, what it is, which, why, how much, and here we have some many another questions. Yes, how do I invest in mutual funds in India, etc. Okay, what for example, what's similar. I don't know. It's just, I think he found what he could found, and that's all. Okay, I'm not sure that he has some sense about these findings, but it works and it's great for our future like projects, for our future solutions. Yes, and let's make our for all lines of data. Yes, so let's extract for all our data, then normalize it. Yes, then make it a subset, find nearest function. It's this find the nearest of our query. Yes, we can return some k most like a k like 10 most similar phrases like questions from our data. Yes, and we sort them from the like from the really similar, yes, to the least similar. Okay, so it is so. And how do I enter the matrix? For example, I want so it doesn't matter. We just lowercase out all our words. So here it is. Oh, I think a sort is wrong. It can be okay. So maybe it went here. Okay. Well, how do I get to the dark web? Maybe yes. From where do I download? That's 2015 from the PC for the PC. How I download, upgrade. So you see that how do I is the most preferable starting of our questions. Yes, and then how do I this here do I, yes, it's here, and then only with do you, how do you, etc. Why here from here? Because I think do I and to make something like the verb, yes, is the more preferable, like more preferable and the more I think strongest relations, yes, between all our data. Yes, this is do I and some verb. Yes, and he found just in it not really how, but how it's vital too. So we have only one here. I don't know why. Maybe matrix, some PC, yes, and maybe some like enter. Yes, it's can be related with PC, like a I think tab, yes, like a button. So and then we move to the how do you and some so how does Trump, I think it's a vital question now. So how does Canada fund, I don't know what this is, America win, yes, maybe. So it's great. So let's go triangulate. Okay, it's business. Okay. So Naruto, it's strange, but well. And why do I ask a question myself? Don't ask, and here it is. Sometimes why don't, and then we have some my or parents or some noun, yes, or some another. So I too, yes. So you see, and here we can create the last one drawing. Yes, one of the last one drawing of our phrases, yes, and here it is. We just can clusterize it, yes, from our from the three labels, yes, like red, green, and blue with k-means. I think I really hope you know how k-means works. So so here three sectors, yes. What is yellow? Submarine, maybe yes. So green, what has how to, and here what is how much. Okay, how long, and we have some clusters which being V. I think it's some with a like caps lock phrases. Yes, here we have some numbers, and here we have some caps lock too, but more, and some special items, special words. Yes, and let's try like a picture with some multiple flip. Here it is. So, well, what we did. So we just talked about three methods of clusterization and low dimensional, like PCA, TSNE, UMAP. And once more, I really advise you to see this method. It's dbscan or hdbscan, hierarchical dbscan. It's really a great tool for clusterization if you want to work with the classical ML tools. Yes, in a company, and you want to go to the interview, to the work in a classic ML team, which like introduce some clusterization tasks and projects. You have to know these four clusterization like instruments for PCA, TSNE, UMAP, dbscan, dbscan. Yes, and maybe else, but it's up to you. So yeah, well, we understand how embeddings works, and we understand how we can use it in some questions. Yes, if we want to get the most similar, for example, 10 not the most similar phrases from our data set, we can create from this work. We can apply to another data set, I think any data set. If you want to just make your txt file with your questions, with your text, with your, I don't know why. So with one, what do you want? Just yes, you tokenize just in phrases, yes, just in words, and then you make a word-to-vec embeddings, yes, and then you, yes, great, you solve the task. So then you can make it some more preferable, yes, for make it some clusters, yes, for these embeddings. So, and like, visualize it, analyze it, yes. And what else? We saw like word-to-vec embeddings, yes, tool, and glove tool, yes. And I think the last one, so we have, I think you can try it's like fast text embeddings, BGE embeddings. I recommend you really to understand how it works, but it's like complex things. And if you want, if you have some time, if you have some knowledges, if you want to make some more practice, you can create your own vec-to-vec, yes, model. It's not really a hard task, yes, it's just, but it's really give you really essential skills and understandable information for it. So I think for today that's all. If you have some questions about word embeddings and some tasks or some what we can do in this, I think, scope, yes, you're welcome.
Could you tell us about the grading for the course?
Grading for the course, yes. First of all, I think not every time, but sometimes I can check if you go on my seminars or not. So it's not really like the main part of gradings, but I think it's essential for, I think, just relations at the exam. Yes. I think the main gradings of our course is your homeworks. Yes, it's will be in the future. Yes, some tests on the lectures, but I don't know about it anything because it's a question from your lecture. Yes, not from Seminarist, not to me. So, and I think that's all. And I think it's what you can do in your seminar, yes, or on your semester, in your semester. But the final so marks, yeah, the final grades, you can find on your exam time. it will be like interview, like an interview at the work. We have like theoretical minimum, what you have to know at the any situation when you go to the exam, even you don't be on any all lectures, yes, even if you grant all seminars, yes, you have to know this knowledge. Yes, you have to know this material. It's like theoretical minimum. Yes, I will ask you some questions from theoretical minimum. You have to answer it, and then you can choose. Or we can like have a conversation about some topics from our course. Yes, it can be word embeddings, it can be some NLP structures, it can be RL in NLP, yes, reinforcement learning, it can be transformers, large language models, training of large language models, etc. It's not, and the conversation, so the purpose of the conversation, understand how, understand how you work with this course and how much knowledge you have. So that's all. I think it's if you have now yet if you still have some questions about grading system, I think you can chat me in our like in our chat. Yes, our own chat, and you can tag me or you can tag Giraffe support, or you can tag the Vladislav G, yes, Goncharenko. You can tag or Radoslav. So, and we, or me, yes, and of course, I really hope that in fast time, in a short time, we will ask all the questions about the grading system. So, if you have another question, so you can answer it. Okay, 3, 2, 1. If there's nothing question, no question. So I really appreciate for this seminar. So thank you very much for coming.
Thank you.
Thanks for the lecture.
Thank you.
Yes, you're welcome. So let's move to another fields. Goodbye.